Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello, everybody. First of all, I would like to say welcome you all to our workshop, En route workshop 2. Our workshop dealing with climate action from theory to practice. It is prepared by me and my PhD student, Farhad Bolouri. This is our contents: introduction, en routes advantages and disadvantages, en routes for postgraduate students, en routes previous studies, from theory to practice, en route simulation. Let's start the question. What is climate change? Climate change refers to long-term shifts in temperatures and weather patterns. These shifts may be natural. Human activities have been the main driver of climate change, primarily due to the burning of fossil fuels like coal, oil, and gas, which produces heat-trapping gases, greenhouse gas emissions. Greenhouse effect. What is happening? Solar radiation passes through the clear atmosphere. Most radiation is absorbed by the Earth's surface and warms it. Some solar radiation is reflected by the Earth and the atmosphere. Some of the infrared radiation passes through the atmosphere, and some is absorbed and re-emitted in all molecules. The effect of this is to warm the Earth's surface and lower atmosphere. Infrared radiation is emitted from the Earth's surface. And this figure shows us natural greenhouse effect and human enhanced greenhouse effect. If you want to teach people a new way of thinking, don't bother trying to teach them. Instead, give them a tool, the use of which will lead to new ways of thinking. En-ROAD is a cutting-edge simulation model used to test climate solutions and generate climate scenarios for the future. En-ROAD is a computer simulation tool developed by Climate Interactive MIT Management. It is designed to help policymakers, educators, business leaders, and the public better understand the complex and interconnected factors that contribute to global climate change and to explore potential solutions for reducing greenhouse gas emissions and limiting global warming. En-ROAD is based on a complex system dynamics model that simulates the interactions between different factors that contribute to climate change, such as energy production, transportation, land use, and industrial production. The model takes into account a wide range of variables, including technological innovations, policy interventions, and social and economic trends. En-ROAD's advantages: Some of the key advantages of En-ROADS are user-friendly interface. En-ROADS features a user-friendly interface that allows users to input a wide range of parameters and assumptions and quickly see the potential outcomes of different policy scenarios. Comprehensive modeling. En-ROADS uses a sophisticated modeling framework that incorporates a wide range of variables, including energy use, land use, population growth, and more. This allows users to explore the potential impacts of different policies across multiple dimensions. Real-time feedback. As users adjust different variables and assumptions in En-ROADS, they receive real-time feedback on how these changes are likely to impact global temperatures, sea level rise, and other key indicators of climate change. This allows users to explore the potential outcomes of different policy interventions in a highly dynamic and interactive way. Customizability. En-ROADS is highly customizable, allowing users to adjust a wide range of parameters and assumptions to reflect their own unique circumstances and policy goals. Educational value. En-ROADS can be a valuable tool for educators looking to teach about the complexities of climate change and the potential impacts of different policy interventions. The tool provides a highly interactive and engaging way to explore these issues, making it a valuable resource for students and teachers alike. En-ROADS disadvantages. While En-ROADS offers many advantages as a simulation tool, there are also some potential disadvantages that users should be aware of, including simplified modeling. While En-ROADS incorporates a wide range of variables, its modeling framework necessarily simplifies many complex systems and processes. This can lead to oversimplification of some aspects of the climate system, which could limit the accuracy of its predictions. Limited geographic resolution. En-ROADS is a global model, which means that it does not capture regional or local variations in climate change impacts or policy responses. This could limit its usefulness for policymakers at the subnational or local level. Uncertain assumptions. Like any modeling tool, En-ROADS is based on a set of assumptions and estimates about future trends in energy use, economic growth, and other key variables. These assumptions are necessarily uncertain, and changes in any one of them could have significant impacts on the tool's predictions. Incomplete policy options. While En-ROADS incorporates a wide range of policy interventions, it may not capture all possible policy options, particularly those that are currently in the early stages of development. Limited user support. En-ROADS is a complex tool that requires a significant amount of expertise to use effectively. While there are some resources available to help users get started, there is limited user support available for more advanced questions or technical issues. En-ROADS for postgraduate students. En-ROADS can be a valuable tool for postgraduate students in a variety of fields, including environmental science policy, economics, and engineering. Here are some ways that En-ROADS could be useful for postgraduate students. Research. En-ROADS can be used as a research tool for postgraduate students who are studying climate change and its impacts. The tool allows students to explore the potential outcomes of different policy interventions and technological solutions, and can be used to test hypotheses and generate insights for their research. Policy analysis. En-ROADS can be used to evaluate the potential impacts of different policy interventions at the global level, including emissions reduction targets, carbon pricing schemes, and renewable energy policies. This can be useful for students who are studying environmental policy or economics. Scenario planning. En-ROADS can be used to develop and test different scenarios for future climate change impacts and policy responses. This can be useful for students who are studying environmental planning or sustainability. Education. En-ROADS can be a valuable tool for postgraduate students who are studying environmental science or policy, as it provides an interactive and engaging way to learn about the complexities of climate change and the potential impacts of different policy interventions and technological solutions. Collaboration. En-ROADS can be used as a collaborative tool for postgraduate students who are working on group projects or research. The tool allows students to share data and insights in real time and to work together to develop and test different policy scenarios. En-ROADS previous studies, we select some previous studies related with our subject, newly published papers. These are climate interactive, transforming climate education and policy with system dynamics and simulations. It's published 2020. And the second example is net zero emissions through the reframing of climate action. It's also published 2020. Last two examples, one of them is viability and economic potential of carbon dioxide removal in the United States. This is also newly published 2021. The last example is modeling uncertainties in climate change, a multi-model comparison. It is also published 2019. Thank you very much for your attention and participation. Now, Mr. Farhad Bolouri will present En-ROADS simulations.
Hello, everybody. Thank you for your attention. Yes, as a second part of this workshop, I want to show the theory to practice and working with the software. For this one, we have first part from theory to practice. This session, we will focus on multi-solving, finding solutions rooted in justice that produce co-benefits in health, resilience, and well-being, while also protecting the climate. Health, social justice, resilience, economics, connection to people and the planet. This is the multi-solving. But if you want to see what is the multi-solving, we can show this one. One action, multiple solutions. For example, you burn less coal. What you obtain in short term, you have the improve health. But in the long term, you have protect climate. Or we can show this one. Any action used to mitigate climate change will need to equitable and just. There are some actions which have equal impact, which should be considered when the step is implemented. Multi-solving one-page guide to the En-ROADS control panel. I will show when we go to the model some minutes later. I will show to you these things in the panel. We have these tools in our model En-ROADS website. You will see these things. These are as the co-benefits. For example, for renewables, you see the reduce air and water pollution, improving health, and for others too, carbon removal, everything. I will show in the website, you will see we have something like potential co-benefits for everything, and I will show you there. Also, we have equity considerations for En-ROADS. Yes, equity, you will see there, I will show. For example, renewables, you have the subsidized programs are often limited to home burners and something like this. And yes, in the equity part in the model, you will see that. We have for this information something like flower. What is the flower? Is framework for long-term whole system equity-based reflection. What it means, it is our floor. You see food and water, jobs and assets, health, well-being and safety, connection, energy industry and mobility, climate protection as our the main point, and resilience. This is the flower framework for long-term whole system equity-based reflection. This is our flower. If we want to see it in details, everything has a definition. For example, job and assets. It's the investment provides meaningful work at a living wage and something like this. And for everything, you have this diagram and definitions. So now let's go to the En-ROADS, to En-ROADS simulation website. And after that, I will come back to these slides to show you some examples. But first, I want to show the website for how is it and how it's working. First, you must type En-ROADS in your Google. When you type that, 1 minute, because we must say to Google, we are not robot. Yes, you will go to the website of the En-ROADS. When you go, the first page of here, you can go to directly to En-ROADS simulation, or of here you can click on the En-ROADS. But here, because it is ready, I clicked. You will go to directly, as you see in the screen, you go to directly to En-ROADS model. This is your work page. It is online system. It has a offline one version, but you can use it as online system. But I want to say that this when you are working, because it is online, you can share it. Scenarios, everybody can see it. But first, I want to show what is the main part of this model, and one point another, because these are the workshop series, so you can go to our first workshop and see more details about the model. Now I will introduce very briefly, but if you want more details about the model and how to work with it, you can go to the first workshop. Some months ago we hold it, and you can see details. But now, for example, I say to you, here you can see the language that you can use for this model. You can see here Turkish, English, Dutch, Spanish, French, and every language that it translated. As simulation, you have, because these are policies in this bottom, you have the policies. If you want, you can reset policies when you do everything. In the end, you can reset. You have assumptions. We will go to there. You have here the reset assumption. If you want to back to the first assumptions, and reset policies and assumptions. You know, when you change these ones, for example, to this and renewables to this, nuclear, net zero carbon, carbon price, energy efficiency. When you click on the reset, all of the policies going to the first point. These are, we have the assumptions. We will go to the assumptions some minutes later. I will show you. Recently, they add the COVID-19 impacts too. You see here, for example, time to recover, pent-up capital investment, and another thing. Here you have the graphs. Default graphs are these two one, global source of primary energy and greenhouse gas net emission. You have another graphs you can choose of here. You have so many graphs, financial cost of energy, for example. But when you say return to the main drafts or default graphs, it goes to these two graphs, global source and greenhouse gas. You have so many impacts, for example, sea level rise, you see, and everything. I return. You have view main graphs, these two. Kaya graphs you have as global population, GDP, energy, sea density, and CO2 emission. These are your Kaya graphs that you can use during publications. You have miniature graphs. Here it minimizes some of the graphs that we have here. And when you click in one of them, it goes to bigger for you, or zoom it for you. And you have actions and outcomes. For example, you did this, and this one. When you say, I want to see the actions and outcomes, it wrote for you. You did this one, coal, oil, natural gas, renewable energy, nuclear. You increase, decrease this one, this amount. And for outcome, you have this one. Temperature increase, CO2, sea level rise, and other things will be like this. What is your outcome of your modeling? Here the metric units or US units show graphs tools and play sound. When you change something, it took a sound, not very important for us. You have here the help. If you want to see more about the En-ROADS, you can click on the first one, guide. You can go to guidance, and here you have anything for any issue. For example, this is for renewable energy. You have videos, you have everything, sources, and you can watch them. Support anything else, and yes, these are not, if you're interested, you can do. One important thing is this one, replay last change. For example, here I increase the population as the maximum. Yes, when you click here, or this one, economic graphs, I choose it at the maximum. When I click, you see, it shows the last action and how it affects our graphs. Only the last change it shows. Here we have the maximize. I will do this because I want to show in the maximized version for you. Here you have the minimized graphs or maximized graphs. Yes, these are the all of the things about the model. I want to reset policies, yes. One another point, and after that I want to show you some modelings with the model, with the CO2, with the En-ROADS simulation. First of all, I want to put all of them in the best way. For example, coal, oil, natural gas, and bioenergy, we decrease. Renewable energy, nuclear energy, NEO, zero carbon, carbon price, energy efficiency maximize, electrification maximize, energy efficiency in building, electrification in industry, population minimum, economic growth minimum, or we can not choose it, deforestation minimum, afforestation maximum, technologies maximum, and methane and other gases minimum. Yes, you can see it. This is the best version of the En-ROADS. If you decrease all of the bad things and increase all of the best things, you can have the 1 degree Celsius increase. What it UN and UNFCCC or IPCC, all of these international organizations about the climate change said about the 1.5 and 2 is enough. You know, it is the it is what we want between 1.5 and 2. But you see, in the best version, we can get to 1. But this is not realistic because we put all of them in the best way. The bad things in the minimum one, the good things in the maximum one. And in this way, you can get to 1 or 1.5, but this is not realistic. I want to just show you if in the world goes in the best way, we will have 1.0 degrees Celsius increase, but this is the best way by 2100. Okay, we can go to our reset all of the assumptions, and I want to show you another things about this simulation to use in your modelings. Here we have 3 dots. If you click here, you can here read more about everything. If you go to this one, this information, you have here, for example, for coal, or I can go to renewables. There is no different for everything. We have these ones. Here you can have some examples, big message, key dynamics, and more important things. Here you have the co-benefits, as I mentioned in the slides. Here you have co-benefits of this one. What's the co-benefits? For example, decrease air and water pollution, can help expand energy access, renewable energy afford opportunities for high and low skilled employment, like this. And you have another thing as equity considerations, and you can read here about them. Here you have some graphs, related graphs, for example, to renewable energy. You have these ones: renewable primary energy, global source of primary energy, low carbon final energy consumption. You can choose them and see their graphs here. You have here so many graphs, but in this one, in 3 dots, you have the related graphs too. Information, graphs. Yes, here you can change some assumptions. First of all, here is the status, like here you have. Here you can choose it by the hand, but here in the 3 dots, you can put it as a exactly number, okay? And say, yes, I want this one, for example. Here you can change some assumptions. If you change only this one, status, this is normal. But if you go and change another things as assumptions, for example, I say renewable breakout year is not 2030, it is 2065, for example, or in one article I read it is 2040, for example. When you change something like these, because they are assumptions, you'll see that will be blue color highlighted because you change some assumptions. And this is another point. Up here you can, yes, do anything. I want to show in another one, for example, in coal 2, you can see here the related graphs, market price, everything. And because I changed something in the renewable energy, now in the graph we have some change. If we don't have this change in this graph. And here you can choose and see what happening. For this one you can do something like this here too. If you read something in articles, books, you can choose them directly here. And if you want to change some assumptions, you can do them here and see what will happening for you in your model. And after that, sometimes you must see what affect your data or your model. For example, here I do so many things, but I want you to pay attention this blue color or CH4 or methane. You see, I choose anything, but methane doesn't change. You see, even afforestation and deforestation. You see, I do everything. I reduce oil, natural gases, carbon price, everything. I do with the model, but any change we didn't see in the CH4 or methane, but only if I click in this one, methane and other gases, you can see many change. Why? I show you with this one. You can see with my last change, it is changed, but with so many changes, we didn't see any change in methane. Why? Because the only related thing to methane is this one. What is that? If we go to the information of here, we know that the methane is coming by the cows and animals in the world. So we must change in that dimension and accept, not the other things, because this aspect is directly related to the methane. And when I change it, you can see so many changes in there. I want to go to the first version because I want to share to you the of the first I want to show, yes, of here. And I want to, this model is based on a system dynamics model, this simulation, En-ROAD simulation. It has 14,000 formula behind it. It is doing in Vensim. It is a system dynamics model. So in system dynamics model, this information, all of them with the exactly parts and with the detail are in our first workshop. But here I want to say, because we have this system dynamics, in system dynamics, a very important thing is time delay. And because of that, I want to show, for example, with one example to you. For example, in industry, when you have electrification or energy efficiency, you will see the changes are not starting exactly from 2023 that we are here. They are starting from 2000, for example, 2035. Why this one? 12 years time delay. You can change them of the assumptions, but you can see in the bottom of it, we have in the behind of the model, we have the time delay automatically because when you do something today, not directly affect because this type of things like electrification, new technologies, and everything else have a time delay between your action or taking your policy and between the results. Minimum 10 years, 12 years. Because of that, you see here, you have, as I said, Kaya graphs for your papers. When you change something, you can see them and you can see the baseline and correct scenario. And I want to show something for you. When you want, you can get your data and you can use them in your Excel file or another paper if you are doing anything else. For example, we have this one. I want to, for example, CO2 emission. CO2 emission, yes, this one. I want this data, just click on the three dots. You can show description, view larger, view in window, or copy data on clipboard. When you see this, it copied for you. Now you can go Excel file. Now you have the data, only click and paste it. It is enough only for paste. You see, now you have the data until 2100, and you can choose them and took them any graph that you want. You go to here, or you want something like this, so you can get them. Just I want to show you, if you want, for your calibration in your models and papers and anything else, you can use them. Every graph in this one here, you have this one. For example, this one, anything. Just go and copy data to clipboard and come to the Excel file and paste them. After that, you can see them, you can use them in your graphs. Not only these graphs, you can obtain your own graphs. Now I want to show you another thing for you. For example, here in the impacts we have sea level rise. These are just examples. For example, this. I choose some opportunities for us to do something. Okay, about the energy, we did this, and you see this model is energy based. Because of that, so many graphs we have related to energy, so many opportunities, assumptions, everything we have related to energy, and other things too. For example, our frustration, deforestation is related to environment, or we have about the transport, building, everything, population. But you see the energy base is very heavy in this model, because this is an energy based model. Yes, I took some things with the energy, and in the left picture you can see in global source of primary energy we did so many things and we have so many decreases. But in the sea level rise, you can see until 2000 or 2070 we don't have any change, and after that very little change we have, because something some of the effects are very not sensitive. For example, sea level rise. You cannot do something today and tomorrow you say, yes, I want to see what's happening, what is it doing for me? No, because it has time delay, and also it has so many times. It needs so many times to do something like the sea level rise. Okay, now I want to show another thing for you about the model. We go to the first step of the model. Yes. Now I want you to pay attention to the degrees. You see, if world remains like today, we have plus 3.6. Yes. Now I took the call to the minimum. We have 0.3 difference. I took the oil, and you can see we have 0.1 another degree difference, and I took the natural gases to the minimum. We have another 0.2. So in the assumption we have 0.5 difference. Yes. So remember it. Now I come to the carbon price, because it is very important policy. Now I increase it to the maximum one. You see we have 1 point, yes, exactly 1.0 difference we have. But if I come to the coal, oil, and natural gases, you see only 0.2, or with the coal we didn't have any change at all in the degrees Celsius. Why this difference? This is the same model. The point is here, because carbon price is very important policy. when you decrease the carbon price, increase the carbon price for the people in the world to very high, it has affected all of these ones, coal, oil, natural gases, even the bioenergy. Because of that, when you have the most affected policy, the other policies effects decreasing. This was another point that I want to share with you. 2-3 another points I want to share with you. After that, we can go to the model and see how is it working. And after that, we have the last slides. Now, I want to take the model to the first point. Yes. For example, here, I maximize renewable energy and maximize the new zero carbon energy. Yes, here you can see for decreasing temperature in our world, it is good. 3.3 we have, and in the first step we have 3.6. So we have a decrease in our temperature increasing in the world. So it is good point. But what happening? The energy uses or energy consumption increases. If we here have the for example, energy consumption. 1 minute, I choose it. Energy, yes. Final energy, yes. Here you can see every time when we talk about global warming or climate change, we say to the people, we say to us that we must decrease energy consumption. But with the renewables and new zero carbon, that both of them are good and positive policies. Why we have increase in our energy consumption? The reason is here. If I go to financial part and cost of energy, yes, here is the point. Because the cost of energy with our policies like the renewable energy, new zero carbon, the cost of energy decrease when it is the economic thing. When you decrease in your cost, you have increase in your demand. You increased your supply. When you increase supply, the cost decrease, so the demand increase. Now you can see in the pictures these economic rules. So you must be careful about the policies and what are you doing in the world, in the real world. Because when you do some policies behind it, you have the economy, environment, society, people. So you must see what are you doing and what it will be affect. Yes, I want to, because of I didn't talk about the assumptions, I want to go to assumptions because when you taking these tools and simulation in your, for example, articles, papers, books, you can use these assumptions. Maybe you want to change them. For example, I want to talk about the afforestation here. For example, this. Yes, here you see afforestation growth time, they said 8 years. But if you say no, in a paper I saw we can do nowadays with this technology and so many growths in our science, no, we can do a jungle in our 40 years, afforestation in 40 years. Or you say we can maximize land of afforestation, not 700 mega hectare. No, we can 800 and other things. You can change, and when you come to afforestation, it will be affected because you change something behind your model. The assumptions. So now when you changed, you will see another results, different results. Another point I took here for share with you is, yes, this one I said, for example, energy efficiency or another things, you can change the start time of where it must affect your model. And you see, as I said, for example, energy efficiency are very doing their effects with time delay, and you can do this start here change, and you see in this graph here, when you change it, it goes very near to 2100, because you took the start here, for example, 2088. So your model is going to until 2100. Only in the last 10 years, for example, you say we have the change. It is not very good. Yes, I said for you to copy the scenarios, copy the data. Here you can share your scenarios directly in Twitter, Facebook, LinkedIn, email, or copy your scenarios. You do this, and this one, for example, and this, and you say, yes, I say this is the change of the world in the next 8 years. And after that, you come here. Up here, you say, I copied my scenarios, and you can share it in your email or WhatsApp, anywhere, with your friends, and they can see like this screen for there, and they can do their change on your model, but you may your model remain as you did, but they can change, or they can go and use assumptions and have you change it, and it is better for them. Yes, two important things is assumptions, is this 3 dots that you can use, and every change you want to do here, or if you want exactly change, you come here and choose from here, and you will see the change. And after that, you come to here and you choose your pictures, graphs you want. And after that, when you see these graphs, you can choose them, choose their data, and go to your Excel file, as I said. And when you copy paste them in the Excel file, you can see what is the difference between them and your modeling, for example, with ANN and other things, ANFIS and other models. And now you can see the collaboration of your model. You can use them for collaboration or test your model. How is the difference for comparison? What is the difference between a system dynamics based model and ANN, artificial intelligence based model, or another things? Or you can have your own system dynamics model with a Venn sim, and in the end you can see how is the difference, or collaborate your model with this model, because this is very big model. So many scientists are behind it. It is developed by MIT University. Professor Esterman is behind this model. Many people from the world are behind this model. 14,000 formula, as I said, is behind this model. So you can do your things that you read in your papers, books, everywhere on the model here, and your model in the Venn sim. And after that, you can comparison and what is the difference between them. Now I go to my slides, the last slides, to share, because now we know what is the model, what's the everything. Now I share with you another point. Yes, grid database, green, resilience, equitable actions for example, transformation. Yes, here, now you know what is this. This is a graph from the model, energy, final energy consumption, as I showed for you, for example, for renewable energy, when we increase it. Yes, here they did something. For example, in Oakland, California, USA, in there, their city will soon be creating more outdoor space and safer corridors for essential travel by foot or bike. Oakland will restrict access to vehicle on nearly 74 miles of city streets, about 10% of city's streets network. So they they did something. Now you come to en-route simulation and you change the related policies. For example, in transportation, energy efficiency, you change and you can see energy, for example, final energy consumption. And as you know, we talked about the co-benefits or multi-solving. Today we talked about what is the co-benefits of these things is longer lives, cleaner air, less noise, active lifestyle, and healthcare things like well-being. Or here you can see about the Colombia. City officially say they will expand bike lanes by almost 50% within 3 years to 145 kilometers and more than double the number of interconnected public transport lines, including overland trains, trams, and cable car lines to 26 by 2030. So yes, you can see they are affecting on the transport. So you will go to the en-route simulation, increase the electrification on the transport, and you see what is happening and what is the result, as you see in the electric share of final energy in transport. Another example in Nigeria. Nigeria's Rural Electrification Agency is partnering with the African Development Bank and World Bank to fund the industrial installation of residual solar system in areas currently without electricity, as well as mini grids of medical and health centers. Yes, here you can see you go to energy supply, renewables, you increase it, and you see in the renewables primary energy demand increasing. And co-benefits of this is energy security, cleaner air, power stay on, saving the money, and the other well-being issues. Or here you have the Jamaica that adopted and expanded and resilient energy plan that emphasized job creation and targets emissions reduction in the country's land and forest sectors. So you go to land and industry emissions, decrease the methane and others, decrease in your deforestation, and you see in the non-CO2 greenhouse gas emissions what is the difference. Or another one in the island, you can see in July Job Simul, they have a package include initiative for job creation and reskilling, transportation reform focused on active travel to improve health outcomes, as well as energy efficiency retrofit for homes and business. Yes, you can see you go to en-route simulation and you change in the energy efficiency, and you can see what's happening in the total primary energy. And here in the bottom we have the co-benefits of it. Here we are going to the last examples. In the New Jersey, USA, they did something about the program about the clean energy, create jobs and promote environment justice about it. Now you can go to the carbon price, increase it, and after that you can see the average cost of the electricity production, because they want to do this, and you can see what is the happening in your graph. This is the other example of ourselves, a climate action with developing 5-minute walking inside and near public center software, published with my supervisors and me. And when you have like this, you had an article or action or idea. If you want, what is the effect of this idea, paper, action in the real world, you can go to the model, You can decrease, increase the related policy because we have the flower. See what is the affecting things of your action or idea, and after that you can go to the model simulation, and after that you can see what is happening with your action. Maybe you ask, I am doing something in, for example, Turkey, Cyprus, another country. What is the effect of it? Or I am doing something local, but this model is worldwide. It is global. Okay, because of that, the model says you must think globally, but act locally. So yes, in the model you will see the change in all over the world, but you must think if all of the world doing my action or doing my idea, what will happen for the world? This is the point. You are thinking globally, but you are doing local. Okay, thank you so much for your attention. And in the end, I want to say all models are wrong, but some are useful, as George E.P. Bach said. But just use the simulation because of seeing what is happening in the future for us. Again, thank you so much, and see you in our other events, workshops, webinars, and conferences. See you there. Bye.
Eğer ki hayatımızda hiç eğer olmasaydı nasıl olurdu? Size şöyle söyleyeyim. Her şey daha az parlak, daha az yeşil olurdu ve daha az parlak yeşil. Çünkü eğerler ormanların derinliklerinde tek bir kibritle devrimlerin kıvılcımını ateşler. Eğerler Nobel ve Guggenheim'ın aklına takılır ve o kodu bu kodu çözerler. Eğerlerle içinizden haykırmak gelir. Eğerler bariyerleri kırarlar. Asla yalnız yürümezler ve aşırı bulaşıcıdırlar. Eğerler aşikardır ve son anda golü atarlar. Eğerler dünü umursamazlar, robotlarla bile konuşabilirler. Karşı takım soluklanırken oynamaya durmadan devam ederler. Sadece basit bir kelime, öyle mi? Hayır. Eğerler asla uyumazlar, hep daha fazla çaba gösterirler. Eğerler bakar, araştırır ve en beklenmedik zamanda ortaya çıkarlar. Eğerler klonlanarak çoğalırlar. Acaba gerçekten yapabilir misin? Yaptın bile. Eğerler aklınıza girmeye çalışan güler yüzlü şakacılardır. Eğerler kapıları açarlar, asla kaybetmeyeceklerini bilirler. Ve biraz gün ışığına her zaman hazırdırlar. Her şey bir eğerle başlar. Çünkü eğerler ne zaman dönüşür, ne zamanlarsa şimdi. Ve şimdi nasıla dönüşür. Nasılsa asıla. Eğerler bakış açınızı değiştirir. Eğerler oyunu değiştirir. Eğerler dünyayı değiştirir. Biliyoruz. Çünkü biz eğerlerle çalışıyoruz. Yakın Doğu Üniversitesi.